Okay, so Module 8, normal distribution. The normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent than the data far from the mean. It means to say that if a distribution is normal, most of our values or most of the data tend to converge near the mean or at the middle, okay, of the distribution. Now, here are some properties of normal distribution. The mean, median, and the mode are equal and lie at the center of the normal curve. The mean, median, and the mode are of equal measures. The curve is symmetric at the center. When we say symmetric, left side is the mirror image of the right side, or the reflection of the right side, okay, and vice versa. That is symmetry. Values are equally distributed on the left and the right side of the normal curve. Now, if the mean, median, and the mode lie at the center of the distribution, then 50% are found on the left side, and the other 50% are found on the right side. Okay. And the total area under the normal curve is 1. Okay. So I was saying, in total, the area under the normal curve is 1. Or if we have a 100% of your distribution, meaning to say 50-50, 50% on the left side, 50% on the right side, pertaining to areas naman. If all in all that is 1, then half of the normal curve is 0.5 and the other half is 0.5. Okay. Then we have the standard normal distribution. So if you have the given raw data or raw scores, you have to convert each score into standard scores. And using these standard scores as points, you can actually graph your scores. Now the graph is a normal curve, and a normal curve is a bell-shaped curve. If you remember, bell-shaped curve. Bell-shaped curve. I believe most of you were product of K to 12, and during your senior high school, you have your statistics or research. So more or less, you already have the idea of the normal distribution. Okay. The standard normal distribution, let me open this. The standard normal distribution has two parameters. The mean and the standard deviation. We are familiar with mean. It is the average. One of the measures of average. And then we have the standard deviation naman. That's one of the measures of variation or dispersion. Okay? How spread, how diverse, how dispersed our data are or is. For a normal distribution, 68% of the observations are within one standard deviation of the mean. 95% are within 2 standard deviations. 99.7% are within 3 standard deviations. Now let me illustrate this. This your normal curve looks like this. Okay? Looks like this. Now the mean, median, mode, and then we convert the measures of mean, median, and mode into standard score. They're equivalent to 0. If at the center is the value of 0, then all the values on the right side were positive, all the values on the left side were negative. And if this is 1, if the area is 1, then left side is 0.5 and the right side is the other 0.5. Or in percentage, if this is 100%, then 50% the left side and the other 50% is found on the right side. Now, what do you mean by this percentage? Say here is your normal distribution. Lowest to highest, distributed from lowest to highest, and then you have the normal curve. And at the center, here lies your mean, median, and the mode. And when we convert them into this scores, that is equivalent to 0. This is 0. We have the positive z scores here. 1. These are the standard deviations, and these are the standard deviations. We have -1, -2, -3. Now, based in our definition, 68% of the distribution is your -1 to +1. This is the 68% distribution, the middle values. 68%. And let's say for example, CSA students, we are one of the CSA students, right? And we are looking for the average height of CSA students. Average height of CSA students. Now, if our mean is, let's say, 165, this is the mean in height, average height. And our standard deviation is, let's say, 3. Let's say 3. So, one standard deviation away from the mean is 168. And one standard deviation away from the mean, but this time on the left side, we have 162. Okay. And 68% of the CSA students have heights between 162 to 168. Okay, that we mean by this one, the standard deviation. 68% of the CSA students have heights between 162 to 168, and it's said to be the normal height. The normal height for CSA students is 162 to 168. That is the relevance of the standard deviation. It tells us what is the standard, what is the standard height, standard weight, or whatever. So any height below or above 162 or 168 will be abnormal. Okay, 168 above the normal, 162 below the normal. And we have two standard deviations away from the mean. This is roughly 95% distribution. Three standard deviations away from the mean. And this is the more or less 99.7% of distribution. So you may want to take a screenshot of this before we proceed to the module. Okay, but how can we graph? The values here? Standard scores. Standard score is a set of scores that have the same mean and standard deviation, so they can be compared. Standard scores, or z-score, is the number of standard deviations above or below the mean. Calculate a z-score, subtract the mean from the raw score, and divide that answer by the standard deviation. Alright, this time we won't be using the symbol x bar for the mean. If you remember, our symbols for the limited mode are x bar, x tilde, x caret, and to which we draw these measures. It affect the symbols, no? Affect the symbol, or we have different symbols to from which we draw the measures. If we draw the measures from samples of our population, then we'll be using the x bar, x tilde, x caret. But if we draw the measures from that population, then we'll be using the symbol for the mean, the Greek letter mu. This is actually the population mean, not the sample mean. Then we have x is the given score, or the raw score, and then we have the Greek letter sigma, my other variant for sigma. We have the standard deviation. Again, we have different symbol for sample standard deviation, and we have population standard deviation. So we'll be using this in converting your raw scores into the standard scores. Right? For example, convert the following z-scores to z-scores, where the mean is 75 and the standard deviation is 5. And we have the values 75, 80, and 58. Converting this scores to these scores means to identify how far or near these values are from the mean in terms of the standard deviation. Okay, I repeat, converting this to their equivalency scores or standard scores, meaning to determine their distance from the mean, right, in terms of the standard deviation. Right, for example, now this is what I meant a while ago, that if we convert the given mean, median, or the mode into the standard score, this would just lead us to 0. For example, 75 is our mean. And using the formula 75 over 5, this gives us 0. Okay. 75. We have 80 here. I 1. equivalent z-score of 80 is 1, meaning 80 is 1 standard deviation away from 75. I repeat, 80 is 1 standard deviation away from 75, and lastly 58 there. 58, if fraction yung lumabas, just toggle this button. So 58 is 3.4 standard deviations away from the mean, but on the left side because this is negative. Okay, negative, meaning to say 58 is lesser or below 75. Repeat, 58 is 3.4 standard deviations away from the mean from the left side of the normal. Any question about the conversion from raw score to z-scores? I need response.
None po.
Thank you. Now we have another example. The height of 2,546 students is normally distributed with the average height of 165 centimeters and with a standard deviation of 3.2 centimeters. We have to find these values. What percent is taller than 170 centimeters? What percent is taller than 162 centimeters? How many are shorter than 159 centimeters? I need specific number of students. How many are shorter than 168 but taller than 156? So meaning in between 156 to 168. Letter E, how many shorter than 172 and taller than 166? Again, in between 166 to 172. Given just these values, the mean and the standard deviation, and of course the number of students. Right, how? Before we proceed to the demonstration on how we solve for these problems, let me enumerate the procedure. We have 5 steps. Okay. These are not included in our module. I just summarize this step, the procedure, and then come up with the steps. So first things first, you have to convert the given score into their standard scores. So first, I repeat, first step is you have to convert the given into the standard score or the z-scores. Second, you have to illustrate the problem in a normal curve. You have to illustrate the problem in the normal curve. And since based on our definition, we'll be relating this problem to their area or to the area of the normal curve. Okay, to the area of the normal curve. And by that, you have to shade the unknown region. Okay. For example, letter A, we need taller than 170. So we'll be shading the values on the right side of 170 kasi taller is greater, right? Taller than is greater than 170. So we'll be shading the right side of 170. So this is 171, 170.5, 172, and so on. Third step. Using the z-score, you can actually find or determine the area from the mean. Okay? I repeat, using the z-score, you can actually determine the area from the mean using or referring to this table. Okay? This table. The areas under the normal curve. One tail. One tail meaning to say we just consider the right side or left side. But since this is, I mean, the normal curve is just symmetrical about the mean, you can just disregard the sign of your z-score and then go over with this table. Okay. This table provides the area between the mean and some z-score. So, for example, your computed z-score is 1.45. Let's locate the value. Observe. Use the ones and tens digit and look for that on our first column. First column here. And then observe the hundreds digit or the digit in the two decimal places. Okay, that is 0.05. Okay, 0.05. So we're looking for 1.4 here. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So the area from the mean to the score whose z-score is 1.45 is 42.4265. Okay. 4.4265 or 42.65% of your distribution. 42.65% will fall under the mean to the score, whatever score here. Whatever score here. That's it, no? That is the third. That is the third. And then the fourth, you have to plan as to how you would solve the area of the unknown region. I repeat, you have to plan how you can solve the area of your unknown region or your shaded region. And then fifth, you have to state your final answer in a complete sentence. Okay. You have to state your final answer in a complete sentence. Let's do that. Let's do that for letter A. Now, in conversion, there's no problem, no? Since this is just the basic part of the solution, the conversion. So let us just verify. Okay, 170 here. 170 is greater than the mean, which is 165, meaning the z-score must be positive, and you have to be very particular with the position of your of your mean and the given score. If you accidentally interchange their position, your z-score becomes negative. Okay, your z-score becomes negative. For example, 165 minus 170 over 3.2. That would give you negative 1.56, which should be on the left side of the normal curve, which is not, kasi 170 is greater. So obviously 170 is somewhere on the right side of 165. So again, you have to be very specific to the position of x and the mean. 170 minus 165 is 5 divided by our standard deviation, 1.56, and you have to round this off the nearest hundreds or nearest two decimal places. 1.56. And then after that, we have to illustrate the given. I hope you already took a screenshot of this, since I'll be deleting this. We have the normal curve. Right? This is the heights of CSA students, no, from smallest CSA student to the tallest CSA student. Have your other students were distributed somewhere within this graph. Then we have the mean, that is 0. Well, in fact, our row height is 165 centimeters. And you don't have to be specific, no? You don't have to be accurate as to where you put the other heights. Like for example, 170. 170 is greater than 165 and its z-score is positive. So just put some 170 somewhere on the right side of 165. Just put somewhere. Just approximate its position. So let's say somewhere here, 170. And its equivalent z-score is 1.56. 1.56. And then we have to identify which region are we trying to solve, or the area we are trying to solve. So we're looking for all set of x who were taller. Okay, taller is greater. I told you that taller is actually greater. Taller than 170. So which region should we shade, or we should be shading? Is it the left or the right side of 170? Need response.
The right side.
Right side, very good. Right side. The direction of your inequality would tell you that whether to shade the left side or the right side of the given value. Since this is greater than, this is taller, we'll be shading this. We're looking for this area. Hindi lang maayos yung pagkaka-shade ko, ha? Ayusin nyo na lang if you're to use paper and pencil. Shade thoroughly, or just use lines or zigzags, whatever. Basta indicated or clear yung shading natin or yung unknown portion. If this is the shaded portion and the table would tell us the area from the mean to 170. Okay, yung table, no? Always from the mean yung table natin. So this would tell us, the table would tell us the area from 165 to 170 using this z-score. Go back to our table. 1.5, first column, first row is 0.06. 1.5. So it is very handy if you print this table, or if it's not possible, just download this and save this in your smartphone or laptop. Okay. So 1.5 and 0, 0, 0, 1, 2, 3, 4, 5, and 6. So this is what we are looking for. 0.4406. So the area from the mean from 0.65 to 1, from 165 to 170 is 0.4406. Okay, how do you think, if this is 0.4406, how do you think we would able to find this shaded portion? We're on the fourth now. We're on the fourth step. We already convert We're done with conversion, we're done with illustration, and we're done with identifying the area from the mean. So we have to decide, or we have to identify, or we have to plan as to how to find the area of the shaded region. Fourth step. Let me give you a hint. This is 0.4405 of the distribution. And based on our definition, half of the distribution is 0.5, right? Is 0.5 of the distribution is 0.5. That is 0.5 and this is 0.4406. How do you think we can solve this shaded portion? Anyone?
Subtract.
Yes, very good. How to subtract? We have to get rid of this portion from the half so that the remaining of that half is actually the greater than 1/7. 5 less than the area from the mean 0.4406. It. Just to use the here is it. And don't be confused to this symbol, ha. Don't be confused. It's trying to state the area from the mean to 170. Okay, all the students whose height is greater than 165 but less than 170, or in between 165 to 170. So that is the area. 0.4406. And based on our illustration, we have to subtract this from the half. Okay, to find the area. Greater than 7. So that would give us 0.65, 0.0594. Let's verify that. 0.5 minus 0.4406. Now, if again you accidentally input interchange the position, no, this would give you a wrong value. This is negative. We don't have a negative area. Area is always positive. So please bear in mind that you have to subtract a smaller area from the larger area. So it's the other way around. Okay, and then we need is we need the percentage. We need the percentage of the CSA students. Just multiply this by 100. And then 5.94%. So fifth step tayo. We have to state our final solution or final answer in a complete sentence. This is the conclusion. Thus, 5.94% of CSA students is taller than 170 centimeters. Question. Hello, question.
Answer.
Let me repeat the 5 steps. No? First, conversion. Second, illustration. Third, the area from the mean. Fourth, your plan as to how you can you as to how to find the area of your shaded region. And then fifth, your conclusion. And your conclusion. Letter B. Letter B, we need taller than 162. Taller than 162. Again, this is the conversion. Verify. 162 minus 165 divided by 3 point negative 0.94. Negative 0.94. And since this is negative, clearly 162 is less than 165. So 162 is located somewhere left side of the mean. Second step. Alright, please take a screenshot of this because this is not included in our module, the illustration. I'll be deleting this on the count of 3. 1, 2, 3. There. Normal curve. Here, and 162 is somewhere on the left side. Its z-score is negative 0.9. We are looking for the students whose height is taller than 162. Taller. Again, taller is greater than 160. Again, we'll be shading the the right side of 160. Shading the right side of 162 since taller. We're looking for the taller. Okay. And then next, the area from the mean. The area from the mean. Okay, the area would tell us, using the z-score, this would tell us the area from 162 to 165. From the mean kasi, di ba? From the mean. So we would know this area using the table. Point 94. Here we have 0.9. We have 0.4. Here 0.4. This is 0.3264. 0.3264. The area from 162 to 165 is 0.3264. How do you think we can solve for the area, the total area of the shaded region? Anyone?
Add po.
Add where? Cheryl. What should we add to, or what should we add from? What should be added to? And what should be added from? Cheryl, or the others? Anyone? What should be added to? What should we be adding?
0.3264 plus 0.5.
Yes, very good, Laika. Sit, Laika. Wait ko lang. Sabihin nyo kung ano, maingay yung electric fan. Maingay ba?
Nan po.
Yung mic ko.
Di man po.
Ayan. Baka sa... Ayan, hindi naman. Baka kasi ano yung mic eh. Anyway. So, yeah, correct. We have, since we already have the half of the distribution here, 0.5, right? We already have the 0.5 here, so all we have to do is to add this area. Find the total area of the shaded portion. So that is 0.5. 0.5 plus. Or since this is plus, we can interchange the position. It doesn't matter. For example, since 5 plus 4 is the same as 4 plus 5. Okay, but 5 minus 4 is not the same as 4 minus 5. Okay, by value nun. 32. Yeah. So we have plus here. 30 to 64 is 0.80 to 64 times 100. That is 84.64%. Our conclusion is that 82.64% of the students is taller than 163.15. Any questions so far? No question? So I assume by now you should know how, when you'll be adding from 0.5 and when you'll be adding from negative, when will you be adding from 0.5 and when will you be subtracting from 0.5? Okay, so the illustration is very important. Let me give you a hint. If just part of the half is your shaded region, you have to subtract from 0.5. Now, if in the normal curve, half of the distribution is already shaded and some part of the other half is also shaded, then that is when you have to add to 0.5 or from 0.5. Right, next. 8.2.C. I think this is smaller than 159. Verify that. Smaller or shorter. And this time we are not concerned with the percentage anymore. We are concerned with specific number of CSA students who were shorter than 159 centimeters. Shorter than 159 centimeters. So conversion. 159 plus 165 division, negative 80. Sorry, this should be 88. This should be 88. Okay? 8. If we round this off, the nearest hundreds, 0.88. Okay, there is a mistake in your module hat from negative 1.86 to negative 1.88. Then illustration. Please take a screenshot of this. 1, 2, 3. And let's draw another normal curve. We have the mean. I mean the normal curve. And at the center, the mean. 65 and 159, right? Somewhere here is the 159. Its z-score is negative 1.2K. We are looking for the area. The CC students who are shorter. So that is shorter is less than 150. This time, we shading the left side of 150. We need shorter. Using this z-score, you can able to find the area from 159. I think this would give us a wrong area since nagbago yung z-score natin. So 1.88. 1.8 here, negative 1.8, 0, 1, 2, 3, 4, 5, 6, 7, and 8. Here is your area from 159 to 165. 0.46. How you can find the area of the shaded portion? Are we going to subtract or add from 0.5?
Subtract.
I subtract. So we have 0.5 here, less than 46. Let's just edit our should be 99. 46. 5 plus 0.46 is 0.0301. And we won't be multiplying 100 anymore, no, since we are not to find the percentage. We'll be multiplying this by the See, total the population of CCA. Okay, CCA students. So if n is 540, then the number of students that are shorter than x is, we have n here, the unknown number of students. We have the capital N, the population, and then we have the area. You count out that is 0.01, 253, 25.3 times 0.0301. And that is 6. Times 0.03. So this is always to know if we are pertaining to person. We are pertaining to person. If there is a point something in your solution, we'll assume that that is a complete person. Okay, because 0.5, 0.25, 0.14 of a person does not exist. I repeat, 0.45, 0.5, 0.20, 0.05 of a person does not exist. So we'll consider that as a complete person. So we have approximately 77. We'll be rounding up. I round up again, round up and not round off. For whatever point here, we'll always be rounding up. Okay, question? So our conclusion is that, no, this should be 77. There are 77 CC students shorter than 159 centimeters. 77 out of 2,540 CC students. Question. Take a screenshot. Alright, no more questions. Let's proceed to the last two. So those were the two cases of problems involving normal distribution. First case is when you be subtracting from 0.5. Second case is when you be adding from 0.5. Okay, letter D and letter E were different cases. So, letter D, how many are shorter than 168 centimeters but taller than 156 centimeters? So in between 156 to 168. Between 156 to 168. So z-score, illustration, area, solving for the area of the shaded region, and then conclusion. Please take a screenshot of this. This is for letter C. 1, 2, and 3. And this is for letter D. We have 2 z-scores. Normal curve. When you are drawing your normal curve, please make sure that your curve is normal, ha? Not too flat, not too thick. Okay? masyadong flat or matambok yung normal curve nyo, hindi na siya normal. This is 165. Looking for the number of students whose height is between 156, somewhere here. This is 156. And this is where here naman is the 160. And there's z-scores. Z-scores 156 plus our mean divided by the standard deviation is negative 0.81. 168 plus 165 is 3 divided by 3.2. We have negative and a positive 0.92. And we are looking for the area in between 156 168. That is a symbol that is x is greater, okay, greater, taller than 156. At the same time, x here is lesser or smaller than 168. And we should be shading 156 using the table, find the area from 156 to 165, right? And 165 to 168. Try to look for that area. So we can just use the -81 and this is the area from 165 to 168. 0.3264. 0.34. This is 0.4975. This is another case. How do you think we can find the area of the shaded region? How?
Pag-add po yung dalawa.
Yes, very good, Darwin. We don't need the 0.5 here anymore. We don't have we don't need the half of the distribution anymore. All we have to do is to add two areas. This is 0.4975 and this is 0.3264. Then the total area from 156 to 168 is their sum. Their sum. 0.4975. Doon na lang mahirap isulat lahat. 4975. We'll be adding, no? We'll be adding the areas. 0.3264 plus 0.4975, that is 0.8239. 0.8239. So 82.39% of CSA students, or that is approximately 540 times 0.82 is 2093, approximately 2093. Yes, this is our conclusion. There are 2,019 PTC students taller than 136 centimeters but shorter than 168 centimeters. And letter E. Last example. Letter E. 172 and 166. So we have find the area from 166 to 172. 166 to 172. Please take a screenshot of this. And we have the distribution. The difference between letter E and letter D. In letter D, the two heights were located on the opposite side of the normal curve. One is on the left side and one is on the right side. But in this case, the two given values were located on the same side, of the distribution. 166 greater than 165, 172 is greater than 172 as well. So 166 somewhere here. 166. Is the other one? And then what's the other one? 72 somewhere here. A the area is of x greater than 166, less than 170. Shading again. Area between 166 and 170. Now, if the area from the mean, let's say I would use variables na lang muna na for these areas. If this is a sub 1, from 165 to 166 is a sub 1. And from 166 here to 172, say a sub 2 naman, how can we find a? How can we find a? For 165 to 166. Wait. Mali yung shading ko. Let me repeat. If this is a sub 1, from 165 to 166, and from 165 here to 172 is a sub 2, always from the mean tayo. Always from the mean. A sub 2, then how can we find 166 to 172? An idea? An idea. Anyone? Hello? Anyone? An idea? Just compare this to letter D. Letter D. The only difference is that the two given values were located on the opposite side. And in this case, the given values were located on the same side. So how? An idea?
Sir, try po.
Sige, Darwin.
Pag-add po yung dalawang value po, tapos ima-minus po siya sa 0.5.
Add the two values. If you were to add the two values, kasi this is the area na eh. Dinagdag mo pa tong area na to, so bali madadagdagan siya dito. Darwin?
No, sir. Kapag sir nakuha na po yung z-score po dun sa 166 tsaka po dun sa 172, pag-add po yon. Tapos po, isusubtract po siya sa 0.5.
Yung z-score or yung area?
Yung z-score po.
Z-score, not the area.
Para po makuha po nun yung area po, sir.
Huwag natin papakilaman yung z-score. Okay? We won't, just like before, no? We just use the z-score to find the area. Let's say, 172, kalimutan ko pala. 172, the z-score here is 2.19. The other one is 0.31. And using the z-scores, we found the area. Let's say ang area from 165 to 166 is a sub 1. 165 to 172 is a sub 2. For example now, how can we find the area from 166 to 172? Now, if if you're telling me is that this area will be added to this area, okay, bali, parang madadagdagan tayo ng another area dito. Then this area will be subtracted from 0.5. That's what you're saying, Nervin.
Medyo magal po. Sorry po.
Sige. So, sabihin ko na, no? We just have, di ba? Knowing that this is already a sub 2, no? From 165 to 172 is a sub 2 already. And 165 to 166 is a sub 1. So, to find this area, all we have to do is to get rid of this side. Right? Get rid of this side from a sub 2. That is basically a sub 2, the larger area, minus a sub 1. Okay? This is the fourth case. Third case is when you add two areas. The fourth case is when you subtract two areas. And be sure that you have to subtract the smaller from the larger, right? So that we can assure the area is positive. Doing that, and these are the area. This is what I'm telling you, the a sub 1 and a sub 2. This is our a sub 2 for 0.4857. This is a sub 1. 0.1217. Subtracting this 2 will have 0.3440. Multiplying that to our given n, the number of students, we have approximately 874. So our conclusion, there are 874 CSA students taller than 166 centimeters, but shorter than 170. Okay, any question?